In today's lesson, toda kuita parabola and curve sketching. Toda kudzidzira kuti tinosketcha sei magraphs and takatarisa quadratic graphs in this particular lesson. So there is a divide, cannot a difference between O-level maths and A-level pure maths. In O-level maths, we had questions that kuti tiplote quadratic graphs. So for plotting graphs, titled a graph paper, cannot a graph page. Then we would plot the graph using the different coordinate points of that graph. As Quadratic advanced level, we do not plot graphs, we sketch graphs. Kureva kuti in your ZIMSEC advanced level pure maths paper, be it paper 1, paper 2, hapana pamunombosangana ne graph paper, because we do not plot, we sketch. So in today's lesson, we want to learn how to sketch quadratic graphs. Now, before we get into it, let us define something, panaba. Saga DFN, I use it for a definition. What do we want to define? Toda could define what a parabola is. So a parabola, it's simply a graph. The graph you get from a quadratic function. That is what a parabola, cannot parabola is. A graph ratinowana from a quadratic function. Be it kuti sketch a quadratic function or plot a quadratic function. That curve, that curvature is called a parabola. So when we look at quadratic functions, quadratic graphs, we have to understand something. So let us write it as a point. Quadratic graphs have turning points. And from now on, we are going to refer to a turning point as a TP. Like that. So quadratic graphs, toziva kuti it's a smooth curve, but that curve is going to have a turning point, and in a moment I'm going to show you what a turning point is. But before we get anywhere, I want to write as a nota bene fact that a quadratic graph singular is one turning point. Saka kana tine quadratic graph rega rega ringorine one turning point. That's a very important point to put across. So let us now look at these turning points kuti chimbori chi uye kuti anenge akambomira sei. Saka turning points are either maximum or a minimum. Saka tine inonzi a maximum turning point and a minimum turning point. Kuti turning point tungureva the point where the curve turns, kana kuti changes course. Let us put down graphs which explain this. But remember that we have what is called a maximum turning point and we have what is called a minimum turning point. So let us say we have a graph, a quadratic graph rakadai so. The turning point is going to be panapa, parukutenera our graph. And this turning point is called a minimum turning point. This is a minimum turning point, TP. And this is what they call cup kanakuti U-shaped. Mazona. That's a minimum turning point. Minimum wacho uri pakuti turning point yacho iri pasi. If we contrast it with the maximum turning point, let us say we now have a curve like this. this now becomes a maximum turning point. Saka iyo inonzi chi maximum turning point. Let me say TP, and that is what they call N-shaped. That's an N-shaped graph. Iro it's a cup kana kuti U-shaped graph. So these are the turning points we have. Minimum turning point nekuti iri pasi, maximum turning point nekuti iri kumusoro. Chinonzi turning point ndipo panotenera our curve, and each quadratic curve has only one turning point. Saka to understand our turning points, taziva the types minimum, maximum, there is something we should also appreciate. We should know kuti the nature of turning points is determined by the coefficient of x squared. Which is A. I want to explain this particular point. Saka kuti tizive the nature of turning points, kuti tizive kuti graph redu rine a minimum turning point kana kuti maximum turning point, even before tatombori plota kana kuti sketcher, we are going to use the coefficient of x squared, which is in most cases A. So if you recall, which understand kuti the general form, so the general form of a quadratic equation, what is the general form of a quadratic equation? It was actually ax squared plus bx plus c is equal to 0. So that was the general form of a quadratic equation when we did that in ordinary level or level maths. Saka a watiri kutaura nde uyu. Kana tichiti coefficient tinenge tichingoreva multiplier. Saka number iri kumultiplier x squared ndo inotiudza the nature of a turning point. Kana titi nature of a turning point, tiri kureva type of a turning point. Either we are going to have a minimum turning point kana kuti a maximum turning point. But how does it do it? Taziva kuti ndi A, taziva kuti coefficient ya x squared, but zvinombofamba sei? Kuti ti understand kuti zvinofamba sei, we have to put this note down. We have a minimum point, kana kuti we have a minimum turning point when A is positive. That is, A is greater than 0. Saka kana A are greater than 0, tinenge tine a minimum turning point. Kana A are positive, tine a minimum turning point. So you have to appreciate this form of like some paradox, some antagonism which is here. Could we have a minimum turning point kana A are positive? Intuitively we could have assumed kuti if A is positive, that is greater than 0, we must have a maximum turning point. But we do not have a maximum turning point. We have a minimum turning point when A is positive or greater than 0. When A is greater than 0 or positive, we have a minimum turning point. So let us put an example panapa. Example yatinayo, it's actually 3x squared plus 7x plus 2. Panapa, zvoreva kuti we have chi, because A is equal to 3, that is, A is greater than 0, we have a minimum turning point. Tichaita curve sketching. If you sketch that curve, you are going to see that you have a minimum turning point. If you plot it rather, you also observe that you have a minimum turning point. Okay, what about the opposite of this? Let us write it as a point. We have a maximum turning point when A is negative, that is A less than 0. That's when we have a maximum turning point. So remember again kuti chinonzi maximum turning point chi, minimum turning point chi. So let us put these graphs here again, but before that we can put an example. Kana tiine something like this, minus x squared plus 5x plus 6. Tukona panapa kuti a is equal to minus 1, because a tukutaura number iri kumultiply x squared, the coefficient of x squared. So since a is equals to minus 1, that is a is less than 0, kureva kuti we have what? A maximum turning point. And when we talk of turning points, ino-ish inenge iri pasi ndo inonzi minimum turning point, and inoitika kana a ari greater than 0, then inenge iri kumusoro inonzi maximum turning point, inoitika kana a ari less than 0. Cherechedzai kamusiyano kari kuitika pano kuti tine minimum turning point kana a wedu ari greater than 0, tine maximum turning point kana a wedu are less than 0. So we can actually put panapa kuti this is a minimum turning point and this is a maximum turning point, just like that.